let's go ahead and draw the 3 flip-flops. And they got a Q and a Q not output each. Data input, a common clear not, which will just tie to a 1, and then a clock input. It's common to all of them as well. Clock. That'll be a series of pulses. And I'm going to label these 1, 2, and 3. And let's think about what happens here. We got a value stored in here. This will be the ones place. I'll call it 2 to the 0. The 2's place, call it 2 to the 1, and the 4's place, 2 to the 2. And on our next clock pulse, the values of D1, D2, and D3 are input into the flip-flop, and they become the values of Q1, Q2, and Q3. This is our least significant digit, and we just want it to toggle. We actually have played with that, where we had a bunch of different clock pulses, where we had individualized clock pulses, and this part doesn't change. We just say for the least significant digit, we can say D3 equals Q3 not. In other words, if we get a 0, in this flip-flop, we'll have a 1 here, put a 1 on the input, the next clock pulse, whatever this value on the input is what Q3 is. And so, or becomes if it isn't already. And so this will just keep toggling back and forth. If it's a 0, we'll have a 1 here, so it'll become a 1. If it's a 1, we'll have a 0 here, so on the next clock pulse it'll become a 1. So that one is easy. Then for the next one, the value of Q2 in the next clock pulse is going to become whatever D2 is now. And so D2 depends on the previous state, and this only gets affected by its own value and the value in a lesser significant digit. What happens up here doesn't affect it. So it's this one affects it and that one affects it. And let's see if we can generate a truth table on what D2 should be based on what Q2 and Q3 are. So call this number 2. D2 is based on Q2 and Q3. So here's our little truth table. Zero, 1, 0, 1, 1, 0, and 1, 1 are the possible values, like possible current values. And if this is interesting, I can say if this is what Q2 and Q3 are, then what I want them to be on the next clock pulse is just the next line in here. So, and Q2 becomes whatever D2 is. So I look at this line, and on the next line, Q2 is a 0, so D2 has to be a 0. I look at this line, on the next line, Q2 is a 1, so D2 is a 1. Now I look at this line, on the next line, Q2 is a 1, so D2 has to be a 1. I look at this line, the next line is then the very first line, and on that one, Q2 is a 0, so D2 has to be a 0. Now, I look at this and I see, if they're the same, I get a 0. If they're different, I get a 1. So that's exactly the output of an exclusive OR gate. So that's D2 is equal to Q3, or Q2 exclusive OR Q3. So it didn't leave too much room up here, so let's try putting an exclusive OR in here. In other words, I better write kind of small. The inputs to it are Q2 and Q3. Yeah, I think I'll draw that over again so I get it a little bit smoother. There we go. And the output is D2. So I think I'll try a different color here. Alright, so that should work. Just imagine if I got, say, 1, 1 on here, that's a 1, and that's a 1. On the next digit, I want both of these to become zeros, and that gets toggled, whatever the next digit is. So, in particular, on the next pulse, I want this to become 0, so I need a 0 there when I got a 1 here and a 1 here. So I got an exclusive, there will be a 1 here and then a 1 here, 2 1s in. So the inputs are both the same. I get a 0 out. Sure enough, there'll be a 0 there. Okay, I think I'm good on that. Let's get to the third one, which I think is going to be the hard one. So this is going to depend on all three of them. So in other words, it depends on Q1, Q2, and Q3. And let's see if we can think about what's going on here. Q1, Q2, Q3, and then D3 is what determines what the value of Q3 is going to be next. D1 determines what the value of D1 is going to be next. D1 is my most significant digit. They got 0, 0, 0, 0, 0, 1, and 0, 1, 0. Then comes 3, 4, 5, 6, 7, and then back to 0. Alright, D1, what this one becomes, again, all I have to do is look at what it is in the next line. So this is what it is. It's a 0 in this line. I want it to be a 0 in the next line. So I'm just looking one line ahead. Look at this line, the next one is 0. Look at this line, the next one is 0. Look at this line, the next one 1. And then it's going to be 1 for a while. Now when I'm looking at this line, the next line is this one, and it's a 0. And here's the deal. If this one's a 0, then D3 is a 0 unless both of these are 1s. So that would be Q1 being a 0 is like Q1 not being a 1, and the only time I get 1 out of when Q1 is a 0, in other words, if Q1 not is true, is if Q2 and Q3 is true. In other words, if both Q2 and Q3 are 1s and Q1 not is 0, I'll get a 1 out. That takes care of the first 4. And then, on the other hand, if Q1 is a 1, so there's one way of getting a 1 out of the deal. And I can say or, and I think I want to write this up a little bit higher. I'm going to copy that and then erase it. So I want to be able to extend this column here. So I'm going to go Q1 not Q2 and Q3 or and that doesn't look much like the or symbol, so or if Q1 is true, in other words, if it's a 1, Q1, then the only time I get a 0 is if both of these are 1s. So that would be Q2, Q3, not. That'll give me a 0. In other words, I got a 1 and a 1 and 2, an AND gate, and then I take the inverse of that, and I get a 0, and that's the only time I get a 0. So if Q2, if either of them is a 0, for instance, then I get a 1. The Q2 and Q3 not gives a 0 if both inputs are 1s, and it gives a 1 otherwise. So there's all those 1s. So in either of these two cases, I get a 1. And if I don't have either of those two cases met, so then, by the way, this term is 0 anytime Q1 is a 1. So it's 0 for all these, and the only way I can possibly get a 1 is if this piece is 1, and I've got that. So let's look at some more columns here. I want to go I think what I want to do is first to simplify this expression. So on that web page, the hyperphysics web page, it said that the OR, one way of writing an OR, a exclusive OR, I'm sorry, a exclusive OR is equal to A not and B or A and B not. So the only way this is a 1 is if they're different, and the only way this is a 1 is if they're different. Again, this is only a 1 if A is a 0 and B is a 1, and this is only a 1 if A is a 1 and B is a 0. So one of them is a 1 if they're different, and we're taking the OR between them. So we got that situation here. We can say, this by the way was D1. So D1 is equal to Q1 exclusive OR Q2 and Q3. Alright, so that's my final answer. I think I'll emphasize that we didn't really have rules of priority for cases involving the exclusive OR. So use parentheses to say what gets evaluated first. So in this expression here for D1, the Q2 and Q3, that entire expression is playing the role of B. So I got the B there, and I got a B not there, and therefore this can be written in terms of the exclusive OR. So let's check our work here. I want to make a column that's Q2 and Q3, and I think I'll put it over to the left there. So that it's right beside the Q1 there. Make it easy to see. So Q2 and Q3. It's a dot. Alright. Q2 and Q3. That's a 1 if they're both 1s, and it's 0 otherwise. So far it's all 0s. That's 4 zeros. Nope, I was looking at Q1. So Q2 and Q3, 0, 0, 0, 1. 0, 0, 0, 1. This is the first case that we've gotten to where they're both 1s. I'm looking for 2 1s to get the 1, otherwise it's 0. So I get a 0, 0, 0, 1 again. 0, 0, 0, 1. And then D1 is presumably the exclusive OR between Q1, so in other words, between these first 2 columns. So D1, what I'm checking to see is D1, 1 if they're different and 0 otherwise. Same 0, same 0, same 0. So far so good. Different 1, different 1, different 1, different 1, same 0. So that's perfect. So that checks out. D1 really is the exclusive OR of Q1 and the Q2 quantity Q2 and Q3. Alright, so we got our truth table, we got our Boolean algebra. Let's see if we can put that in there. So I need an AND gate for Q2 and Q3. I need to AND Q2 and Q3. So I'm going to put that I'm going to try putting it right here. There's an AND gate, and Q2 and Q3 were the ones going into that exclusive OR right there. So I'll put a dot there indicating that it's really connected to it, and a dot there indicating that it's really connected to it. Then that goes into an exclusive OR. And then something else goes into that exclusive OR. It was, I think, Q1. So, yeah, Q1 goes into that exclusive OR. I think I got a different color going here. Then the output of that is D1. Alright, so if it's all zeros, a clock pulse comes in. With Q1, Q2, and Q3 being zeros, Q3 not is going to be a 1. That clock pulse toggles this becomes a 1. And Q2 is a 0, and Q3 is a 0, so on that same toggle I get a 0 into this one. It already had a 0, but it gets a 0. And then on that same toggle, when it was all zeros, I get this will be a 0, and let's see, the Q2 is a 0, so that's going to be a 0. So I got 2 zeros in, that'll be a 0 there. So this becomes 0, 0, 1. I'm going to check out just one more. That'll be, let's say we got 0, 0, 1 in here. I think I'll check out 2 more. So the next case, this should become a 1, and that is 0. So because when this is a 1, the Q not output is a 0, the next clock pulse will make this a 0. Before that clock pulse again, this is a 1, that's a 0, that's a 0. I'll have a 0 into this exclusive OR, and I'll have a 1 into this exclusive OR. So there's going to be a 1 on D2, and sure enough, on the next clock pulse, I want this Q2 to change to a 1. It's like I added 1, I got a 0 and a carry, and the carry goes over here, making that a 1. And again, starting with a 0, 0, 1, the Q2 input into this AND gate is a 0, so that's it's got a 0 out. I only need one of them to be a 0 to get a 0 out. One or both, so I just checked on one. I got a 0 there. And there's a 0 from the other one, so I got 2 zeros into an exclusive OR gate, making a 0 there. So yeah, on the next clock pulse, this will become 0, 1, 0, just as it should. And then I'm going to jump ahead. Suppose I said I was only going to do one more case, so let's make it the last case. Suppose I counted all the way up. This thing was working. Got up to 1, 1, 1. On the next pulse, everything should turn into a 0. So this one does turn into a 0 because it just keeps getting toggled. 1 here means Q3 not is a 0. 0 on D3 on the next pulse, that'll turn to a 0. Okay. Now again, all ones before that clock pulse. So I got a 1 here, and that makes a 1 into this input of the exclusive OR, and I got a 1 into the other input of the exclusive OR. So both the same. That's going to put a 0 here. Next clock pulse, this becomes a 0. Okay, but before that clock pulse, everything's a 1. And let's see what I got. I got a 1 into this AND gate from there. A 1 into this AND gate from there. So this AND gate will have a 1 on the output. So I got a 1 into one input of an exclusive OR, and then the other one's a 1 as well. 2 ones in give me a 0 out. That means on the next clock pulse, because there's a 0 wait at D1, Q1 turns into a 0. So sure enough, the whole thing goes 0, 0, 0. So I haven't completely checked it, but just for time, I think I'll stop there. This was the third item that we considered. I'll put that number 3 back in there. And I think I also better draw a line if somebody just jumps to the end of this tape. Yeah, this A plus A exclusive OR B, that was just a generic expression. It was from the reading assignment where it showed that an exclusive OR can be expressed in terms of the more fundamental AND and OR operations as A naught and B or A and B naught. And this was the first line all by itself. Yeah, this was very short and very simple and very much like the last time we dealt with a counter. So because we can't get at the individual clock inputs, they're inside the IC chip, we need some logic circuitry to make it so that one clock pulse increments the count no matter what the count is at the given instant. So that represents the solution for problem 3 from the digital logic homework assignment.